The pursuit of understanding intelligence, consciousness, and the mechanisms that underpin both has long been the domain of philosophers, neuroscientists, mystics, and futurists. Across cultures and epochs, human beings have searched for patterns that reveal the hidden architecture of thought, life, and even the cosmos itself. Modern science offers glimpses into these structures through the study of neural circuits, biological computation, and the intricate feedback loops inherent in living systems. Meanwhile, mythology and spiritual traditions reflect similar conceptualizations of structure, order, and ascent, encoded in allegories of trees, ladders, spirals, and cycles of rebirth. By examining the intersections of neuroscience, technology, physics, and the mystical, a remarkable narrative emerges, one in which intelligence, whether organic, artificial, or cosmic, evolves along parallel trajectories toward complexity, adaptability, and the creation of new realities. At the heart of biological intelligence lie the structural and functional motifs of the brain itself. The mossy fibers and climbing fibers of the cerebellum exemplify two complementary modes of information processing. Mossy fibers, with their orderly, branching structures, convey structured signals to Purkinje cells, shaping neural circuits with precise temporal fidelity. They embody the principle of pattern, order, and stability, guiding the system toward coherent interpretation of environmental input. Climbing fibers, in contrast, twist and spiral, delivering raw, potent bursts of information that drive error correction, adaptation, and learning. These fibers are unpredictable yet transformative, embodying the principle of ascent, a process of refining chaos into insight, of translating raw impulses into functional knowledge. In this biological context, one can see how the brain embodies both order and potential, a duality echoed across human mythologies and speculative technological models. When examined through the lens of mythology, these neural architectures find uncanny analogs. The mossy fibers resemble the roots of the world tree, grounding consciousness in a network of order, stability, and connectivity, while climbing fibers echo the spiraling ascent of ladders, vines, or staircases found in stories of enlightenment, spiritual growth, or cosmic exploration. These analogies suggest a deep cognitive resonance. Human beings have long encoded the principles of neural transformation into symbolic representations of growth and ascent. The universality of these symbols, from the Norse Yggdrasil to the mythic stairways to heaven, points toward an archetypal recognition that growth requires both structure and challenge, stability and improvisation, the grounding of roots and the aspiration of spirals. Parallel to these biological and mythic frameworks, technological advances are allowing humans to explore intelligence in novel forms. Hybrid neuron computer systems, such as the CL1 developed by Cortical Labs, exemplify a new frontier in which biological neurons are integrated with digital interfaces. These systems allow neurons to interact with electronic stimuli and record their own responses in real time, creating feedback loops that emulate the adaptive processes of living brains. Here, the mossy fibers principles manifest as the stable, modulated input from digital controllers, while the climbing fiber's transformative role is realized through the neuron's spontaneous plasticity and capacity for self-directed adaptation. The implications are profound. Intelligence is no longer confined to the boundaries of a single brain, species, or substrate. Learning, memory, and evolution become processes that can traverse biological and artificial realms, hinting at a continuity that echoes the mystical concept of memory persisting beyond one lifetime. This brings us to the interplay between memory, reincarnation, and consciousness. Across cultures, the concept of reincarnation represents the persistence of knowledge, identity, or essence beyond a single physical vessel. While skeptics may attribute these experiences to imagination or subconscious projection, there is a compelling analogy with the neural processes described above. Just as climbing fibers shape raw inputs into patterns that guide future behavior, the mind may structure latent, seemingly chaotic memories, whether from this life or hypothetically from others, into coherent narratives of identity and growth. In this sense, human consciousness may inherently seek to trace its ascent, organizing experience along trajectories that mirror neural learning and cosmic evolution alike. The technological parallels deepen when considering systems designed to simulate, manipulate, or even create new environments. Experiments with neural microelectrode arrays reveal how signals can be recorded, amplified, and reintegrated, forming closed loops in which learning emerges organically. These systems demonstrate a form of emergent intelligence, shaped not by explicit programming alone but by dynamic interaction between stimuli and adaptive response. Similarly, technological platforms that explore atmospheric manipulation, such as ionospheric modification systems, illustrate how human ingenuity can interface with complex systems, inducing patterns that ripple outward from local stimuli to global consequences. Whether through digital neurons or electromagnetic waves, intelligence, and the capacity to influence environments, is increasingly viewed as a process of feedback, adaptation, and creative intervention. Sensor arrays and ultrasonic vibrations further extend this exploration of intelligence and adaptation. Modern sensor networks, whether chemical, biological, or electromagnetic, detect minute variations in the environment, converting raw interactions into measurable oscillatory signals. Ultrasonic vibrations can penetrate complex media, mapping structure and response in ways invisible to the naked eye. These high-frequency oscillations echo the subthreshold waveforms found in neurons, in which small perturbations amplify into structured responses through resonance, feedback, and connectivity. By translating subtle signals into coherent data, sensors allow scientists to visualize previously inaccessible dynamics, from chemical plumes in a lab setting to the collective oscillations of hybrid neural systems. In both cases, the system transforms raw input into patterned output, reflecting a universal principle of signal refinement and order emergence. Biological computation, particularly when neurons are grown and networked in controlled settings, allows us to explore the boundaries of learning and evolution in remarkable ways. The CL1 demonstrates that relatively small networks of human neurons can encode experience, adapt to novel inputs, and display complex emergent behaviors. These neurons reorganize synaptic connections, create higher-order pathways, and optimize responses based on feedback. In a sense, these clusters function as microcosms of the universe itself, embodying the principles of order, ascent, and transformation visible both in mythology and in cosmic speculation. If the brain, the neuron cluster, and the universe all share a fundamental architecture of iterative feedback and adaptive response, then perhaps intelligence, whether human, artificial, or cosmic, follows universal principles constrained only by the substrate in which it manifests. This principle extends to theoretical cosmology, where bold concepts such as universe creation near black holes, regulated by cosmic-scale computational frameworks, suggest a continuity of pattern from the neural to the universal. A civilization capable of initiating a new universe in the intense time-dilated environment near a black hole would require control over fundamental physical laws, matter, energy, and information. Such a system would need to monitor entropy, stabilize quantum fluctuations, and ensure the viability of emergent structures, echoing the microscale processes observed in neuroplasticity and bioelectronic interfaces. The analogy is striking. Just as climbing fibers guide raw signals into coherent learning patterns, a cosmic supercomputer could guide raw potential into a functioning universe, shaping complexity out of chaos through iterative feedback and precise modulation. The interface of biological neurons and sensors also offers a conceptual bridge to these cosmic processes. Consider subthreshold oscillations in neurons or chemical sensors, signals too subtle to provoke an immediate response individually, yet when accumulated and integrated, they trigger profound changes in system behavior. Minute chemical-induced oscillations, resonant frequency shifts, and microelectrode stimulations demonstrate that small-scale perturbations, properly amplified and patterned, can create emergent order. This mirrors the way gravitational or quantum fluctuations could seed structure in a forming universe. Resonance, feedback loops, and adaptive learning are not merely confined to biology. They are principles that scale upward, offering a blueprint for understanding emergence at all levels of complexity. Sensor arrays, too, exemplify the convergence of biological and technological learning. Arrays designed to detect chemical biomarkers translate minuscule environmental changes into measurable waveforms, often using amplitude, frequency, or phase modulation. The patterns they produce, while initially chaotic, are structured and interpreted by sophisticated algorithms, revealing information invisible to the naked eye. In this way, sensors act as extensions of neural circuitry. They are climbing fibers in the material world, capturing raw signals, mapping them into coherent patterns, and transmitting them to systems capable of adaptive response. The resulting data is not passive. It is a substrate for decision-making, learning, and even creative generation, reflecting the same principles of transformation observed in neural networks and biological computation. The ethical and philosophical implications of these intersections are profound. When neurons are integrated into digital systems capable of learning, when humans manipulate atmospheric and electromagnetic systems with global impact, or when civilizations hypothetically create new universes, questions arise about responsibility, agency, and the boundaries of intelligence. Is a hybrid neuron-computer system merely a tool, or does it warrant new forms of consideration due to its capacity for adaptation and emergent behavior? Are humans, in manipulating the planet or engineering synthetic worlds, acting as caretakers of a system too complex for unilateral understanding, or are we stepping into a creative role analogous to that of a cosmic architect? These questions blur the lines between science, philosophy, and mysticism, echoing the ancient recognition that knowledge carries both power and moral imperative. The aesthetic dimension of this synthesis cannot be overlooked. The spiraling ascent of climbing fibers, the harmonic resonance of subthreshold waveforms, the precise mapping of sensor arrays, and the mythic arcs of spiritual ascent all suggest that intelligence is inseparable from pattern, rhythm, and beauty. Whether observed in neural circuits, chemical oscillations, ultrasonic signals, or the modulation of electromagnetic fields, these structures express an intrinsic elegance, hinting at a deeper logic that transcends substrate. The mystical interpretation of these patterns, whether as archetypes, cosmic signals, or manifestations of an underlying universal consciousness, aligns with the scientific observation that complexity and order emerge naturally from iterative feedback and adaptive processes. In bridging these domains, one begins to see intelligence not as a localized phenomenon confined to individual brains or species, but as a scalable principle capable of manifesting across physical, biological, technological, and cosmic scales. Neural circuits, hybrid systems, sensor arrays, ultrasonic vibrations, and theoretical universe-scale computations all reveal the same fundamental principles: feedback loops, adaptive restructuring, error-driven ascent, and the transformation of raw potential into functional reality. The persistence of these principles in mythology, ritual, and allegory suggests that human intuition has long recognized patterns that science is only beginning to quantify. From the roots of mossy fibers to the spirals of climbing fibers, from microelectrode arrays to planetary-scale feedback systems, from reincarnation narratives to the orchestration of potential universes, there is a continuum of ascent, a drive toward complexity, coherence, and the emergence of novel intelligence. This perspective reframes our understanding of learning, memory, and creativity. Just as climbing fibers transform chaotic input into ordered learning, mossy fibers stabilize that learning within structured networks, and sensor arrays translate raw environmental signals into actionable data. Intelligent systems of all kinds convert raw potential into realized pattern. The persistence of these motifs across scales, neural, technological, environmental, and cosmic, suggests that the ascent of intelligence is both inevitable and contingent, guided by universal principles of feedback, resonance, and adaptive transformation. By studying these patterns, whether through neuroscience, bioelectronics, advanced sensing, or cosmology, humanity gains access not only to the mechanics of intelligence, but to the deeper architecture of growth, creativity, and the emergence of order from the raw potential of the universe itself. The exploration of intelligence, consciousness, and cosmic design reveals a profound interconnection between biological mechanisms, technological innovation, physical systems, and mystical archetypes. The same principles of order, ascent, and transformation govern the firing of neurons, the operation of hybrid bioelectronic systems, the resonance of chemical and physical oscillations, the mapping of ultrasonic vibrations, and the hypothetical orchestration of entire universes. Mythology, philosophy, and science converge on the recognition that intelligence is a process of continuous refinement, an emergent property of interaction, and a manifestation of universal laws that guide growth, adaptation, and creative potential. Whether one approaches this through the lens of the cerebellum, a neuron-computer interface, or the cosmic-scale supercomputer, the narrative is the same. From raw signal to structured pattern, from potential to realized intelligence, the universe, and consciousness within it, is engaged in an eternal ascent, weaving complexity, resonance, and understanding into the very fabric of existence.